am I supposed to calculate how far my guitar pick flew?
Well, that flew pretty fast. I would say at least 1.38 meters per second.
What are you doing in my house?
Why, helping you, of course.
How can you help me?
Your problem can be solved using physics or projectile motion. In physics, we have something called projectile motion that can be used to calculate how far your pick flew.
Oh, I mean, we could just go the easy route and measure how far it landed from a little ruler or something.
That's ridiculous.
Why do you say that?
Because we have to use physics.
Well, okay, I guess.
Alrighty, let's get to it. Okay. We're done.
Set this problem up in a T-chart. The first column is constant velocity and the second column is free fall. The aspects of the T-chart are independent of each other and are connected through time.
How can we use this?
Well, we can input what we already know into the spaces to get time.
What do we already know about the problem?
For instance, we know the acceleration due to gravity is negative 9.8 meters per second. The distance you were above the ground when you flung the pick was negative 0.97 meters. So in here, since it's dropping, we're making a negative value. The initial velocity in the y direction, because it's a classic 1 problem, is 0 meters per second. And the velocity that the pick flew in your hand is 1.38 meters per second.
How do you know that?
I have my ways.
Whatever. How do we solve the problem from here?
We would have to put what we know into the kinematic equations to find time.
Which kinematic equation do we use?
An equation that can be used to find time but does not have a final velocity as a variable. X equals VO times t plus 1/2 at squared.
So once I put the values in solve, I will get time?
Yes, for x you plug in your y. For x you plug in your y value here. For initial velocity, since it's 0, it becomes 0. This whole thing becomes 0. Plus 1/2 times at squared. From here you plug in the values that you know. Since initial velocity is 0, anything multiplied becomes 0, so this just becomes 0. This n becomes negative 4.9 t squared. To isolate the t, you divide by negative 4.9, and you get approximately 0.2 is equal to t squared. To find t, you find the square root of that, which ends out to be 0.5 seconds. From here, you can just plug the 0.5 seconds into this time, which connects with this time. And then to find how far your pick flew, you can just multiply using x equals vt. Shouldn't we just x? Yeah, let's cut that later. To find your distance that your pick flew, you can use x equals vt, plug your values in. 1.38 times 0.5 equals x, which comes out to 0.69 meters, which is 27 inches.
And don't forget to check your answer with this.
There. It lines up. We did it. Hello? Oh, I mean, we could just go the easy route and measure how far it landed from a little ruler or something.
That's ridiculous.